Hello everyone, welcome to Learn with Joy by NH. Today we learn the concept of limits and continuity. Firstly, we have to let us know about the what is the limit. So here the limit can be applicable for the function. Okay, so here y is equals to f of x is set to tends to a limit L as x tends to a, which means here the function f of x has the one of the limit that sets to be a constant. Okay, one of the constant, that constant will be applicable to f of x, then it will be obtains the indeterminate forms. So hence here the constant which is not exactly equals to x. Okay, so it will little bit lesser than or little bit greater than. Okay, so simply we called it as the mod of f of x minus L is a as smaller as than that the value of the limit. Okay, so that limit is called the L. Okay, so here we called it as the simple limit. Here the limit will be expressed as by using the limit x tends to a f of x, which is equals to L. L is called the limit. So their small difference will be obtained. Okay, here the limit can be have particular properties. That means limit x tends to a f of x, when the limit will be applied to the given function, it will be obtained as the constant, or we may call it as the determinant forms. Okay, let us see about the what are the determinant forms in a later form. Now first we have to show the properties. Okay, next second property will be limit x tends to a f of x plus or minus g of x, which means the sum of the terms or the subtraction of the two terms will be represented as the individually limit part. Okay, now individually limit will be applicable for the given functions. Okay, later multiplication of the two function, here the multiplication of the two functions also be represented like the individual will be applicable for the limit to a given function. Okay, limit x tends to a of f of x and limit x tends to a into g of x. Okay, like this division also be a represented, both numerator and denominator will be, the limit will be applicable for the individually, hence the denominator term should be a not equals to 0. So next limit x tends to a nth root of f of x will be represented as nth root of limit x tends to a f of x. So here this is the property. So in the previous we said that constant which should be a determinant form. So let us know about the what are the determinant for indeterminate for. Indeterminate form can be represented as the there is a no value. Okay, so here the indeterminate form will be obtained as the 0 by 0, infinity by infinity, 0 into infinity, infinity minus infinity, 0 to the power of 0, infinity to the power of 0, 1 to the power of infinity. Okay, so these are all terms as the indeterminate forms. So there is a no consideration value. Okay, next determinant form. So determinant form will be represented as like this: a by 0 is equals to infinity, 0 by a is equals to 0, infinity into a is equals to infinity, infinity into infinity is equals to infinity, 0 into 0 is 0, 0 minus b is equals to infinity, a minus infinity is equals to minus infinity, infinity plus infinity is equals to infinity. So here all these are the determinant form which will be considered under the constant values. Okay, so let us show the some of the example to knowing the how the limit will be applicable for the given function. Here I am taking the algebraic functions. In this algebraic function, firstly we have to be represents the or applicable the limit to the given function. If it is obtains the determinant form, it is said to be a valid. If it is obtains the indeterminate form, it will says that there is no consideration of the value. Okay, so they later we have to be simplified it. So here we have to be taken the simple problem. Okay, so here when the limit will be applicable for, so 1 square plus 6 into 1 plus 4. So that is, it will be obtained as the 1 plus 6 plus 4 is equals to 11. 11 is the constant term, so hence we called it as the valid. Next, the 4 will be applicable to the given function, that is 4 cube plus 4, 1 minus 4. 4 cube means 64 plus 4 divided by minus 3. The answer will be 68 minus 3. So similarly, we have to applicable the root function. Here the first we have to applicable the limit value. Later we have to apply the root value. Okay. So here root of limit x tends to 2, 36 minus x square is equals to root of limit. Okay, so x tends to 2, 36 minus x square, what we have to the equation. Okay, so here it will be represented as root of 36 minus 2 will be applicable. 2 square is equals to 36 minus 4, which is equals to root of 32. So 32 is not to be a perfect square, hence we have to represent the root of 32. Hope you all understand this concept. In the next video we will meet on the continuation part of the limits. So if you like this video, share and subscribe the channel. Thank you.